Hello everyone. Today's our topic is chapter number 3. You are in your syllabus, unit number 3, that is principle of steady state heat transfer. Principle of steady state heat transfer. Okay. The subject of heat transfer already you learned in semester number 4, that is heat transfer, but the basic fundamentals of heat transfer are necessary in transport phenomena, like that the Fourier's law for heat conduction, what is thermal conductivity, what is steady state heat transfer. So that is the most important part in transport phenomena. So in your syllabus, the chapter number 3 is principle of steady state heat transfer, in which first topic is Fourier's law of heat conduction. Fourier's law for heat conduction, that is here. Okay, first of all in heat transfer we know that conduction, convection and radiation. We all know that the definition of conduction, convection and radiation. Basically Fourier's law is generally described for heat transfer in conduction. Okay, so let we start here. Fourier's law for heat transfer, heat conduction, or in other words molecular energy transport. Okay, so from here, consider a slab of solid material of area A located between two large parallel plates at distance y apart. Look like similar to our first chapter in which we already see the figure. Okay, already see this figure. Look like a Newton's flow pattern. જેવી રીતે ન્યૂટન્સનો લો છે બરાબર વિસ્કોસિટી માટે, એવી જ રીતેનું કંઈ અરેન્જમેન્ટ છે. તો સિમ્પલી લુક લાઈક ધેટ કે કોઈ બે પેરેલલ પ્લેટ છે, ધેટ ઇઝ હિયર, કે જે પ્લેટ છે આ છે બરાબર, આ બે પ્લેટ છે. તો ઇનિશિયલ ટેમ્પરેચર એનું T0 છે બરાબર, T0 બરાબર, અને એની લેન્થ છે એટલે કે એનું ડિસ્ટન્સ બંને વચ્ચેનું y છે. ઓકે, અને t is less than 0 એટલે કે 0 टाइम करता ઓછા ટાઈમે, that means टाइम स्टार्ट नहीं हुआ, that in isolated condition at solid initially at temperature 0 temperature. Okay, so consider a slab of solid material of area A located between two large parallel plates, that is प्लेट डिस्टेंस y अपार्ट, दैट मीन्स उसका डिस्टेंस क्या है, y डिस्टेंस है. ओके, जो मैंने अभी फिगर में बताया. वी इमेजिन दैट इनिशियली एट टाइम t लेस देन 0 अ सॉलिड मटेरियल इज एट द टेम्परेचर 0. ओके, एट सीन दिस फिगर एट इनिशियल टाइम t. ओके, इनिशियल टाइम t इज लेस देन 0, तो उसमें क्या है हमारा सॉलिड है, और दैट इज एन इनिशियल कंडीशन. ओके, देन नेक्स्ट, इफ टेम्परेचर इंक्रीज T0 टू T1, अभी टेम्परेचर इंक्रीज हो रहा है T0 टू T1 एंड एट T टाइम टू 0 एंड 0 टाइम पर, तो लोअर प्लेट सडनली रेज टू टेम्परेचर T1. जो ये नीचे का प्लेट है दैट मीन्स वो क्या हो जाएगा, थोड़ी सी उसको वेलोसिटी बढ़ जाएगी. दैट मीन्स लोअर प्लेट है वो क्या हो जाएगा, दे आर रेडी टू फ्लो. ओके, सो एंड देन नेक्स्ट, सो at t equal to 0 the lower plate is suddenly brought up to slightly higher temperature at T1 and it is maintained at that temperature. Okay, so as time proceed the temperature profile in the slab changes. Okay, जैसे जैसे टाइम बढ़ता जाएगा then after the profile of temperature also that can be changed, and ultimately a linear steady state temperature distribution is attained shown in figure. Okay, so here we can say that जैसे जैसे टाइम बढ़ता जाएगा at a small t, at a small t, what happened, that is velocity is increase, velocity is also increasing, and at temperature T1, y at t of y of t point, similar to here for a large of tree, जैसे हम फ्लो बढ़ा रहे हैं बराबर टेम्परेचर के साथ, तो जो प्लेट है वो क्या हो जाएगा मैक्सिमम वेलोसिटी के साथ, लुक लाइक दिस, ओके। व्हेन दिस स्टेडी स्टेट कंडीशन हैज बीन रीच, दैट मीन्स एक ऐसा टाइम आएगा, दैट मीन्स no more increase the velocity at that time, and for the steady state condition, that means constant rate flow of heat flow through a slab is required to maintain the temperature difference from delta t T1 minus T0. So it is found then that sufficient small values of delta t by the following relationship, that is Q by A is equal to K into delta T upon Y. In heat transfer we know that what is the Fourier's law. So Fourier's law state that rate of heat transfer or rate of heat flow by conduction through a uniform material is directly proportional to the area nominal to the heat transfer and temperature gradient in the direction of heat flow. Similar definition is also given here, that is the rate of heat flow per unit area is proportional to the temperature decrease over the distance y. That means rate of heat transfer Q equal to, okay, rate of heat transfer through a by a conduction through a uniform material is directly proportional to the area nominal to the heat transfer and temperature gradient in the direction of heat flow. Here I write the equation, Q is equal to minus K into dt upon dN. So what is Q? Q is rate of heat transfer, okay, and what is K? K is the thermal conductivity. K is thermal conductivity. What is A? A is area nominal to the heat transfer into what is dt upon dN. First of all, T is the temperature and N is the distance, okay, and dt upon dN, it's called temperature gradient. So similar equations are here, that is Q upon A is equal to K into delta T upon Y, okay. The constant of proportionality K is thermal conductivity, as I said that K is thermal conductivity of the slab. So this equation is also valid for a liquid or gas is placed between two plates, provided that suitable precautions are taken to eliminate convection and radiation. So the local rate of heat transfer or heat flow per unit area, that means our flux Q by A. If we A को यहाँ पे डिवाइड करेंगे, that means Q by A, that is heat flow per unit area, जो हो जाएगा हमारा heat flux, is the positively wide direction is designated by QY. In this nomination, this equation become this, okay. इसमें क्या करते हैं कि जैसे कि Q by A कर देते हैं, that means उसको हम क्या दे देते हैं, उसका नाम हम वो रखते हैं, that means heat flux, इसको डिनोट किया है QY, that is minus K dt upon dy, and here similar that Y is distance, okay. And what that indicate that negative sign is indicate that जैसे हमारा टेम्परेचर है वो क्या है कि डिस्टेंस जैसे बढ़ता जाएगा उस हिसाब से हमारा जो टेम्परेचर है वो क्या हो जाएगा, कम होता होगा. सो जैसे डिस्टेंस बढ़ता है तो टेम्परेचर है वो क्या हो जाएगा, कम हो जाएगा. सो दैट्स व्हाई नेगेटिव साइन इंडिकेट दैट. So this equation which serves to define K is the one-dimensional form of Fourier's law of heat conduction. That is Fourier's law for heat conduction in one dimension. So for three dimension, or we can say that the all three dimension or coordinate direction, the laws can be written as here. If that is here. Okay. If the temperature varies in the all three directions, then we can write an equation like this, equation number 2 of कोऑर्डिनेट डायरेक्शन. दैट मीन्स हमें हीट फ्लो के ऊपर जो हीट फ्लक्स है उसके आधार पे हमें थ्री डायमेंशन का जो इक्वेशन लिखना है वो कैसे लिख सकते हैं. दैट इज फॉर एक्स डायरेक्शन. अगर हमारा हीट फ्लो हीट फ्लक्स वो किसी भी एक्स डायरेक्शन में है, दैट मीन्स क्यू एक्स इक्वल टू माइनस के डेल टी अपॉन डेल एक्स. ओके. इन अदर वाई डायरेक्शन, अगर वो वाई डायरेक्शन में भी है तो दैट मीन्स क्यू वाई इक्वल टू माइनस के डेल टी बाई डेल वाई. एंड फॉर जेड डायरेक्शन इट इज क्यू जेड इक्वल टू माइनस के डेल टी बाई डेल जेड. If each of these equation is multiplied by the appropriate unit vector and the equation are then added, we get that for the unit vectors and scalars quantities, generally the final equation for Fourier's law of heat transfer, okay, we can say that Q equal to minus K delta T. And what is here? Q is the heat flux, thermal conductivity, and delta T, that means dt अपॉन dn. और इसकी जगह पे हम डेल टी बाई डेल एक्स, डेल टी बाई डेल वाई एंड डेल टी बाई डेल जेड लिख सकते हैं, विच इज द थ्री डायमेंशनल फॉर्म ऑफ फूरियर्स लॉ. ओके.